Hi everyone, this is James Tompkins and welcome to a mini lecture, if you will. Here I'm going to talk about the relationship between levered and unlevered beta, and of course as I proceed I'll explain what I mean by all of that. As an agenda, I'm going to start off with what's known as the debt tax shield, and the reason I'm even going to get into the debt tax shield is because it's necessary to use the debt tax shield in developing the relationship between levered and unlevered beta, which is the goal of this mini lecture, if you will. So I'll tell you a little bit later what I mean by the relationship between levered and unlevered beta, but I'm going to start off with debt tax shield. So what is the debt tax shield? Well, what does a shield do? Just in general, what does a shield do for you? Protects you from something, right? So what do you think this shield is protecting you from? Well, it's probably protecting you from taxes, which means you're paying more taxes or fewer taxes if it's protecting you from taxes. Fewer taxes, right? And what do you think is enabling you to pay fewer taxes? Well, the fact that you have debt. And that's why you have what's called a debt tax shield. Because you have debt, it shields you from taxes. Now what is it about debt that shields at least a corporation from taxes? Well, interest is tax deductible, right? And because interest is tax deductible, say you pay $100 in interest. Does that mean you'll have $100 more of taxable income or $100 less of taxable income? $100 less of taxable income, right? And because of that, it's going to save you on your tax bill. So basically, it's going to save you on your tax bill every year, and the present value of all of those savings is what is known as the debt tax shield. So what I'll do is I'll make up some numbers and I'll also use symbols, and based on some assumptions, we'll develop a formula for the debt tax shield. So let's say a company borrows, say, $100,000, and I'll call D the amount of debt. Let's say the interest rate is 10%, also known as the required rate of return of debt. And let's say the marginal corporate tax rate is 30%. Now I'm going to assume that we have perpetual debt. What is perpetual debt? Debt that goes on forever. By the way, is that realistic? Could you go to a bank and say, I want to borrow $1 million forever? I don't think so, right? That's not realistic. But what is it realistic as far as, let's say a company has a target capital structure where they want to have $1 million in debt on an ongoing basis. Once the debt comes due, what could they do? Well, they could pay it off and then they could borrow it back again, right? So in any case, for the sake of the derivation of this formula, I'll assume perpetual debt. Alright, so we have $100,000 that we borrowed. The interest rate's 10%, so how much do we pay in interest every year? Well, let's see. 100,000 at 10%, that's $10,000, right? So the amount you borrow times the interest rate, so that's $10,000 per year is what you pay in interest. This is the corporation, so D times RD. Okay, so here's my question. Because you have this $10,000 that you pay out in interest, does that mean you're going to pay more in taxes or less in taxes? Will you have more or less in taxable income? Less, right? Because this is tax deductible. I mean, let's do it the other way around. Suppose for whatever reason you had $10,000 of additional taxable income. Then would you pay more taxes or fewer taxes? More taxes, right? And if the tax rate was 30%, how much more would you pay in taxes? Well, 30% times the 10,000. So you would pay 3,000 more in taxes. But this is the opposite, right? This is reducing your taxable income by 10,000. So if your taxable income is reduced by 10,000, then would you pay more taxes or fewer taxes? you'd save on taxes every year, right? Well, how much would you save? Well, the $10,000 in less in taxable income multiplied by the tax rate. Or in other words, $3,000 is what you'd save every year forever. So at this point, if we use symbols, we've got the DRD, that was the $10,000 of interest. Now we multiply it by the tax rate, and so that's how much you're saving. And that's how much you're saving every year forever, because we've assumed what? We've assumed perpetual debt. So if we draw this and see what it looks like, here we have it time 1, 3,000, time 2, basically going on forever. This is what we save in taxes. Now, the debt tax yield basically says, well, what is the equivalent of all of these guys at time 0? What is one single number? So here's my question. To bring all of these guys back to time 0, do I need a discount rate? I do, right? This is like time value of money. You need cash flows and a discount rate. So the riskiness inherent in these cash flows was directly related to the riskiness of which financial security? You want multiple choice? All right. Was it equity? Was it debt? Was it preferred stock? And the answer is debt. And therefore the discount rate that I would apply to this would be basically the required rate of return of debt, or the interest rate. In other words, 10%. So if I figure out the debt tax yield now, this is a perpetuity. So can I apply my perpetuity formula? I can, right? And if you go back to time value money, multiple cash flows, basically the formula for a perpetuity is C over R. So 3,000 over 0.1. If the first value is at time 1, the solution is one period earlier. So this comes to $30,000. If we look at the formula, because it's perpetual debt, notice that the two required rate of returns of debt, or RDs, they cancel. And so basically, assuming perpetual debt, we get that the present value of the debt tax yield is the corporate tax rate, the marginal corporate tax rate of 30% times the debt amount, $100,000, or in this example, $30,000. So, by the way, just as an example of stressing why it's so important to understand the assumptions when deriving this stuff, because it's really important when it comes to using judgment in bridging theory with practice. So what's a bottom line assumption in this formula? Well, you might say, okay, well, it assumes the tax rate remains the same over the periods. All right, true. Very true. Yep. When we apply this, we have to be cognizant of the fact that Congress or whoever may change the tax laws down the road. What else? Well, it assumes perpetual debt. That's true. I mean, after all, the company, when they refinance, they may have a new debt amount, or for that matter, they may have a new required rate of return of debt down the road. Because the interest rate maybe 5 years later when they refinance would presumably change, so that's true. What about this, though? And this is one which really hits the nail on the head in using judgment as to how you could reasonably or unreasonably possibly apply this. Is this only true if a firm can actually shield profits? In other words, if they're making money? Does the government tax corporations on losses? It doesn't, right? So if this was a company that was losing money, would this debt tax shield do it much good? It wouldn't, right? So if I had to think, all right, well, this is more likely to apply to, say, an IBM, which has a history of steady, profitable, mature, cash cow kind of cash flows, or a company like Delta, where sometimes it's making a ton of money and sometimes it's losing a ton of money, and it's already been through one bankruptcy reorganization and so on and so forth. Well, for which company would it be more appropriate? IBM, right? In any case, that's the debt tax yield, the marginal corporate tax rate multiplied by the debt, given the assumptions that we've made. So we now move on to levered and unlevered beta, and I want to start off with a reminder of, well, what does beta mean? So for example, if I told you that the beta of IBM's equity was 2, what would that mean? Well, if the market went up by 1%, IBM would be expected to go up by 2%. Or if the market went down by, say, 3%, you'd expect IBM to go down by 6%. So, in real life, therefore, what two items, or what two pieces of information do we need to estimate what beta is? Because after all, in theory, is beta like a stock price where it changes on a second-by-second basis? It is, right? But we're forced to estimate beta. Unlike stock prices, there's no ticker tape that says, hey, this is the beta right now. So think about what it means, the sensitivity to market movements. So what two things do we need? Well, we need something to proxy for the market, maybe the S&P 500 index or the New York Stock Exchange index or something like that. And then what else do we need? Well, we need to see how much IBM stock has changed. So for example, we might go back, if time zero is today, we might go back 100 days and say, hey, it looks like when IBM went up by this 0.9%, the market, however you measure that, maybe it's the New York Stock Exchange, that went up by 0.4%. The next day, IBM dropped a little and the market dropped a little, and so on and so forth. And so if I wanted to, could I run a regression and check on the sensitivity on average of IBM to the market? I could, right? And maybe it looks something like this. Maybe, here are all the 100 points that are plotted. Maybe a line that most closely goes through those is something like that. And so maybe we find, hey, when the market goes up by 1%, it looks like on average, IBM's stock or equity value goes up by 2%. So we're going to estimate that IBM's equity beta is therefore 2. Now let me ask you a question. When all these price changes happened and when this regression was run and so on and so forth, was it a secret, or did the market know that IBM had debt? Well, they knew it, right? I mean, that's public information. I mean, IBM publishes its balance sheet and those kind of statements quarterly, and so that's public information. So just to sort of stress the fact that, hey, this beta, it's IBM stock or equity beta, but just sort of stress the fact that this is our regular beta, and by the way, this is knowing or incorporates the fact that IBM has debt. We're going to call that the levered equity beta, what I'll call the BL, the levered equity beta. So here's my question for you, okay? What if, when this regression had been run, if I could somehow say, hypothetically speaking, I wonder what that beta would have been if we could back out debt. If we could somehow say, I wonder what it would have been if there'd been no debt. And by the way, that's what we call the unlevered beta. So it's a hypothetical number, because yes, IBM had debt, but what would it have been if, for whatever reason, we wanted to say, well, what would this number look like if there were no debt? Well, if there were no debt, then as an equity holder, ceteris paribus, would things be more risky for you or less risky for you? Well, when there is debt, are there more folks getting paid before you or fewer folks? More folks, right? Because who gets paid first, the debt holders or the equity holders? The debt holders, right? And so if there's more people getting paid before you as an equity holder, does that make things more risky or less risky for you? more risky, right? And so in other words, if this levered beta of 2 reflects not only IBM's business risk, that's the assets, but also the fact that there's a bunch of debt holders that get paid before you, and then you say, well, I wonder what this number would have looked like if, hypothetically, I could back out the debt and imagine nobody gets paid before me. Then would there be a higher beta or a lower beta than 2? It'd be less, right? And so the unlevered beta might be something like maybe 1.2. By the way, I just made up that number. Yeah, and the only stipulation of when I made this number up was that it be what? At least related to this guy, the 2. That it be something less than 2. So in any case, that's what I mean by levered and unlevered beta. The levered equity beta, or levered beta for short, that's just your regular normal stock beta. It incorporates, number one, hey, what are you doing with my money? That's IBM's business, if you will. And by the way, how many folks get paid before me? You know, that's the debt they have, so that's the normal beta that you're working with. And then this guy, the unlevered beta, that's something hypothetical. That's like, well, if I could somehow magically, hypothetically, fantasyland, whatever you want to call it, I recognize it's not real. But if I wanted to back it out for analytical reasons, then I wonder what it would be. So that's what I mean by levered and unlevered beta, and based on some assumptions, what we're going to do is we're going to develop a relationship between the two. So assumptions, or assumption number one, is basically going to be, I'm going to assume perfect markets, and the only benefit of debt is basically going to be this debt tax shield, which means I'm going to assume perfect markets with everything except the present of corporate taxes. And so basically what you can think of is that the value of a firm with debt, I'm calling that VL, can be thought of its value as if it had no debt, that's the unlevered value, plus the debt tax shield. So here's the only benefit of debt. So I'll talk more about that a little bit later with the diagram. But first I'm going to get into some notation. I'm going to call D the market value of debt, E the market value of equity. I'm going to imagine something called the unlevered beta, which we've discussed what that is, and the regular levered beta. We can talk about a firm's debt beta. We're going to have a marginal corporate tax rate. VL is just basically the value of the firm, but we're just stressing that this company happens to have debt, so that's why we've got the L in there. And VU is the value of the unlevered firm. You know, what is the value of the firm as if, hypothetically speaking, it had no debt. So let's move to the diagram I was talking about. And what I've done is I've made up some numbers as well as some symbols. So the typical, if we look at right here, right, this side, the G plus C or the 40 plus 6C, the typical way of valuing a firm, I would do what to these two numbers to say, hey, this firm is worth $100. I would add them up, right? So the typical normal way of valuing a firm is just the sum of the market value of debt and equity. Okay? So that's this D plus C here. Now, this next thing, this is the biggest mind twister, if you will, in this whole derivation. Because another way of thinking of the value of the firm with debt is you could say, you know what? The fact that the firm has debt, we're going to assume that the value, not the market value of debt itself, but the benefit that debt brings because it's debt as opposed to equity. So for example, is there an equity tax shield? There's not, right? There's a debt tax shield, and we've calculated the debt tax shield as being, you know, the marginal corporate tax rate times the principal amount of debt. This is hey, you know, because we raised money that includes debt, this is the value that it brings. So not the value of the debt itself, it's not the 40, but it's the value that it brings because it's saving us taxes. So we could think of the value of this firm as being this value that debt brings And this value that debt brings, by definition, is it fair to say that it's related to anything to do with debt? It is, right? So here's the value that debt brings that is only there because we have debt, and then this VU is basically the value of the firm involving everything else that's unrelated to debt. In other words, the value of the unlevered firm. So I made up some numbers, okay? I said, all right, well, imagine the value that debt brings. The debt tax yield is 20. Well, this 80 you could think of as a plug. Or you could think of as any value that's unrelated to debt, or the value of the unlevered firm. So if you can get your mind around that, if you can get your mind around the fact that, hey, the value of the firm can be thought of as simply the sum of this market value of debt and equity, the 40 and the 60, that's what you're typically used to. But it could also hypothetically be thought of as, hey, the benefit that debt brings, that's the debt tax yield, plus anything else, that's the value of the unlevered firm. You can think of that as a plug too. If you can understand that leap is probably the toughest part in the derivation of this whole formula. So given that, here's my question. Should a weighted average, or should the overall risk on this side be equal to the overall risk on that side? In other words, should the overall risk on the right-hand side of the balance sheet be a reflection of the overall risk on the left-hand side of the balance sheet? It should, right? I mean, it's balance sheet. Okay. And so therefore, when I talk about risk, we're going to talk in terms of betas. And so therefore, is it fair to say that a weighted average of betas on this side would equal a weighted average of betas on that side? It should, right? And so that's basically how we're going to derive this formula. So a weighted average of betas on this side, we're going to set equal to a weighted average of betas on that side. Now, before I give you a big scary formula, whoa, let's get rid of that. Yeah, before we get to that big scary formula, let's think about what this is going to look like. I'm gonna give you some choices of betas. First of all, is there a beta of all this stuff? Is there a beta that applies to this debt guy? There is, right? Is there a beta that applies to this equity guy? There is, right? I mean, I mean, you can have could I have a beta of my toothbrush? I could, right? I mean, what's the beta of my toothbrush? Well, again, let's remind ourselves of what beta means. Imagine, first of all, imagine the market just absolutely went through the roof, just skyrocketed today. How much would you pay me for my toothbrush? Nothing, right? Well, what if the market plummeted? How much would you pay me for my toothbrush? Nothing, right? So in other words, is it fair to say the value of my toothbrush is highly sensitive or completely insensitive to market movements? It's totally insensitive, right? And therefore the beta of my toothbrush is what? It's 0. So my point is that there are betas that apply to all of these guys. So I'm going to give you a choice of betas here a minute. Okay? So imagine that we have, a beta of debt, a beta of equity, that's our levered beta, that's our regular normal beta, and an unlevered beta. Okay? So here are our choices of betas. Okay? Beta of debt, beta of equity, and beta of unlevered. Okay? So what beta would apply to this guy, the D, the debt? Would that be the unlevered beta? Would that be our equity beta or levered beta? That's the regular beta, or would it be the debt beta? The debt beta, right? So we've got we've got a debt beta associated with that guy. What about right here, the equity? So here we have equity that reflects, hey, what are you doing with my money? And also, how many folks get paid first. So this is our regular levered equity, right? So what beta is associated with that guy? The beta of debt, the unlevered beta, or the regular equity levered beta? That's the BL, right? Okay. What about this guy here? The value of the unlevered firm. What beta is associated with that? Well, that would be the unlevered beta, right? And what about here? Here we've got something multiplied by debt. Well, the beta of the debt, right? So now we know which beta is associated with which of these things to get a weighted average. Well, if we're talking about this D right here, well, if we use these numbers, what is the weight of debt on this side? It's 40%, right? 40 divided by 40 plus 60. So now, do you think we're ready for a scary formula? All right, let's do it. All right, whoa, okay. Now that looks very scary, maybe, but really it's not that complicated. For example, look at this, D divided by D plus C. That's basically the percentage debt, 40 over 40 plus 60. So this is just the amount of debt. And we said what beta was associated with this debt? The beta of debt, so there's the BD. So it's the same thing here. Here's the equity beta, and this is percentage equity. Here's the amount of percentage of the debt value here, or the benefits that debt brings in terms of debt tax yield. You know, there's the weighting, and that guy's associated with the debt beta, and here's the weighting of the VU, and unlevered beta is associated with that. So all that's saying is a weighted average of betas on this side equals a weighted average of betas on that side. So I'm going to make one more assumption. I don't have to assume this, but I'm going to assume that debt is riskless. And if debt is riskless, then what is the beta of debt equal to? 0, right? Which means, does this term go away? It does, right? What about this guy? Does that go away? It does, right? So what we're left with is that equation right there. By the way, again, stressing assumptions, bridging theory with practice, for what kind of firm is debt more likely to be riskless in the application of this? A delta, sometimes it makes a ton of money, sometimes it loses a ton of money, or an IBM, which is steady, mature, cash cow kind of thing. IBM, right? In any case, if we take that equation, there are no more assumptions. If we do a little algebra and rearrange it, we've achieved our goal. Basically, based on some assumptions, we've got levered beta in terms of unlevered, and vice versa. And so this was all theory, and the reason that I have it is because it can be useful in bridging theory with practice. At least I use it in some of my cases. Anyway, this was James Tompkins, and I hope it was helpful. Take care.